When you need to focus on building, do you want to get bogged down by your database? MongoDB is an intuitive, flexible document database that lets you get to building. MongoDB's document model is a natural way to represent data so you can focus on what matters. MongoDB Atlas is the best way to use MongoDB. It's a global cloud database service that gives you all of the developer productivity of MongoDB, plus the added simplicity of a fully managed database service. You can get started free with MongoDB Atlas at mongodb.com/atlas. Hi, this is Scott Hanselman. This is another episode of Hansel Minutes. Today I'm talking with Isabel Cachola. She's a PhD student studying computer science at Johns Hopkins. How are you?
Doing well.
So I am checking out all of your cool publications. I really enjoy looking at PhD people and the things that they build and how they get interested in them. It seems like you're very interested in language and natural language processing. Is that something that you fall into or something that you decide as a teenager that I want to study this?
No, I definitely just fell into it. I think it's actually a little bit of a funny story how I discovered it, because when I first started my undergraduate studies, I didn't even know that this field existed. And the way that I found it was I studied mathematics in undergraduate, and I was part of this program called the Directed Reading Program. And it's where they connect you with a graduate student, and you do a semester of research or self-study, something along those lines. And I did this program in the fall of my sophomore year. And because I was a sophomore, I had no idea what I wanted to do. And so my mentor told me to go on Wikipedia and just Google, just look up math and just go down the Wikipedia tree to find something interesting. And I did that, and I found a page on computational linguistics, and I thought, oh, this looks really cool. So I went to my mentor, and she was like, yeah, this sounds great. And we did a full semester studying machine translation from a probabilistic perspective, and I just absolutely loved it. So from there, I took a class, I did a mentorship, and I started getting involved in research from there. And it was just this sort of snowball from that one program, that one Wikipedia page.
That's amazing. And then you found your, if not your life's work, certainly your work for the next chunk of your life.
Yeah, that was 4 years ago. And I've just been doing that ever since.
Wow. One of the things that I'm interested in is how people get to this place. My children are 12 and 14. So the idea that in 10 or 12 years, my 14-year-old will theoretically be where you're at. Do you feel that things really take a turn at 18 or 20 or 22? When does the brain fire where you could start having conversations about probabilistic math as it relates to natural language processing? Because it's certainly not in my 14-year-old's area right now.
No, I don't know if there's a moment where all of a sudden I was just able to talk about natural language processing. I started off studying math just because I really liked math. And it was just this sort of process of getting deeper and deeper into a subject until I found my little niche. So when I started college, I didn't even know that this field existed. And it was this sort of snowball moment of finding my little place in research.
Mm-hmm. And I noticed in some of the papers that you've worked on, like one that you did a couple of years ago on analyzing and inferring the intentions of vulgar expressions. Is that a combination of the linguistics department and the math department working together?
Yeah, so natural language processing sits at this really cool intersection of computer science and linguistics and mathematics. So that was work I did in collaboration with some people in the linguistics department. And it's really cool to look at how we can find these intersectional ways of creating new research.
Do you feel like traditional academia likes to put things into silos and call it the Department of Foo and that department does its own thing and they don't hang out with the other people in the other department. And now we're starting to break those walls down.
In my experience, it's very university dependent. So that research was at the University of Texas at Austin, and UT is very good, in my opinion, at having collaborations between the linguistics and the computer science departments. But I've definitely heard from a lot of academics that they wish that there was more cross-departmental collaboration. And a lot of these silos sort of have these historical reasons for why they exist, and sometimes boring bureaucratic reasons. Like, this is the department we're going to put this funding into, right? So I do think that there needs to be some sort of way to encourage this cross-departmental collaborations, because I think that that's when we can get this really cool research, when we're pulling from different people's knowledge pools.
Can't you just run over there and say, like, this is so cool, I got this idea, we need to study the thing?
Well, that's essentially what I did. But maybe that's something that needs to be encouraged a little bit more.
Mm-hmm. So this paper on vulgarity, you go from a corpus of tweets and a corpus of text, and you start categorizing and applying math to that. When does this go from the academic and the theoretical to something that can be applied? And how do you think about application versus pure research when you're working on a paper like this?
I think this is an interesting question, because I think that everyone sort of has different opinions about how much research should be applied and where their personal research lies on that spectrum. Because on the sort of far end of the spectrum, we have people working on computer science theory, and they're really going deep into the math of how a lot of these systems work. And your average software engineer may never actually see that side of it. The vulgarity work, I thought, was closer to the applied side, because it has a lot of really important implication in terms of, for example, censorship. If we are going to be categorizing certain tweets as hate speech, for example, we want to make sure that we are actually only censoring hate speech and not censoring minority communities who may just be expressing themselves.
Interesting. Okay. My kids are on Chromebooks right now, and they're learning. They're being managed by the school district, and I was surprised in 2020 that that text and censorship, which is effectively what they're doing, they're hiding, trying to hide what they believe is vulgar content from the kids, is still kind of in its nascent form. They're just doing, basic string lookups. There's no intelligence behind it. There's no sentiment analysis. Why do you think that, even though stuff like this exists where you've done research and we have a lot of analysis of natural language, that systems are still using the most naive way of filtering text?
I think it's because whenever you start using any sort of machine learning or artificial intelligence algorithm to do these sorts of filtering, you have to be very careful. And so there's a little bit of hesitation for actually putting these systems into production, because they actually are still relatively new. We want to make sure that they're doing what we think they're doing, that they're not hiding things that we actually want to be seen, or vice versa. These sort of like naive string matching algorithms, while they might not be perfect, they're at least easy to understand. So you know what the system is doing.
That's very interesting, because as you were saying that, I'm thinking, well, anything must be better than the trash that we have right now, which is, probably a list of dirty words and a contains function. It's, as you said, though, it's very easy to understand, even though it's clearly imperfect. But if we applied something like your paper, a layperson would have trouble understanding why something was blocked and why something wasn't blocked.
Right. And I think especially when we're getting into blocking specific content, we want to be careful about what we're blocking. And we know that machine learning algorithms can have certain biases. And I think that a lot of engineers, rightfully so, are skeptical of putting these systems into production without having a full understanding of what those biases are.
Mm-hmm. I read the paper on vulgarity, and one of the things, again, myself speaking as a layperson, I was surprised about is what I thought was the rather, and again, it's my opinion, my initial reaction, the small data set, it's like 8,000 tweets or something like that. Why aren't they, why isn't a million tweets? Why are data sets a certain size? How do you decide what should be large and what should be small?
Yeah, that's a really good question. Data is one of those things that, as machine learning researchers, we're always coming back to because it's sort of the foundation of everything we do. The sort of boring answer to that is that data isn't always easy to collect. So we can always, connect to an API, download a ton of tweets, but that doesn't really mean anything if we don't have any labels for those tweets. And depending on what labels you're looking for, sometimes it can be harder to collect than others. And a lot of these data sets require human annotation, which is more expensive to collect than, say, like automatically downloading labels for a specific data set. And the sort of spectrum of how difficult that data set is to collect comes back to like the data that you're working with and the domain that you're working in. And so in another one of my papers, we were working with scientific texts, and that one was even more difficult to collect. And we had an even smaller data set because it required expert domain knowledge to be able to annotate that data.
Interesting. So if we downloaded a million tweets and we were going to infer the function of a particular word and whether or not it was intending to be offensive or intending to be vulgar or attempting to express a relationship or whatever, a human being has to look at that and tag it. Do people get together and vote on whether that word means what we think it means? And do you have arguments about individual things within the data set?
Yeah, so the reason why we need humans to go through and tag this data is for something called supervised learning. So it's when you give a model a set of data with the labels being known. And so these known labels are these human annotated labels that, as I was saying earlier, we collected. Um, the way we go about collecting those labels kind of depends on the specific data set. For something like offensive tagging, for example, like you're trying to go through these tweets and decide whether or not these tweets are offensive. A really common method is to have these tweets tagged multiple times by multiple humans and try to find agreement within the annotators. And so you're sort of trying to tap into these annotators' intuitive knowledge about what is and isn't offensive.
Interesting. Okay, so then moving to your more recent research, which is called TLDR, Extreme Summarization of Scientific Documents, then, as you said, it gets more and more difficult because then it's not just about opinions or about colloquialisms. It requires deep knowledge of the paper and the topic. Otherwise, you won't know if you got it right. Maybe you could explain what extreme summarization is and why that's a problem.
Yeah, so extreme summarization, loosely defined, is when you're trying to generate a very concise summary of a document. And so for this paper, we took a lot of inspiration from the XM paper, which introduced a data set of extreme summaries for news articles. We wanted to do something similar, but for scientific documents.
So, as a layperson, would this be something that I could use to get a sense of whether or not I wanted to read something, or is this for scientists? Is this is for indexing services that index scientific papers and allow them to be searched? What is the practical application?
So I think with this paper in specific, we were looking more at the use case of scientists. So scientists, when they're looking at a long list of papers and they're trying to decide which ones to spend their time reading, it can be a little bit of information overload. And the current common workflow that scientists have is maybe they read the paper, maybe they read the abstract, and from there, if they're still interested, maybe they go and read the conclusion or something along those lines. And this is not a very quick process. And you're just here deciding if you want to read the entire paper. So we are hoping with this project that we would sort of help the scientists overcome this information overload and this increase in rate of publications to improve their workflow. That
Hmm.
being said, though, I do think that there is a potential application for lay people where you're sort of modeling for people's background knowledge. So the extreme summary I might give to one of my colleagues might be different from the extreme summary I'd give to, say, a journalist who's writing an article about my work. And I do think that an interesting direction for future work would be modeling how people's background knowledge influences what sort of summary we want to give them.
Wow. Actually, that sounds really interesting to have some kind of a slider bar of expected knowledge from, eighth grade till PhD, and you give them the TLDR that is appropriate to their background knowledge.
Right. And I think that this is something that we as humans do intuitively. When I'm talking to my family about my work and I tell them what my paper is about, it's very different from when I'm telling my colleagues what my paper is about.
Today's episode of Hansel Minutes is sponsored by Datadog, a monitoring and analytics platform for cloud scale infrastructure and applications. Datadog provides dashboarding, alerting, application performance monitoring, and log management in one tightly integrated platform, so you can get end-to-end visibility quickly. Be proactive with your monitoring strategy and catch issues before your clients are impacted. Start managing the overall health of your environment with a free Datadog trial. Visit datadoghq.com/Hanselminutes to get started. How different are the TLDRs? And again, for folks that don't know the acronym, too long didn't read, the summaries that are generated by a technique like this versus the abstract that the paper writer wrote as their own human written TLDR?
So in the paper, we define TLDRs to be one sentence summaries, usually between 15 to 30 tokens in length. Abstracts on average are 156 tokens in length. So TLDRs are quite a bit shorter than abstracts. And so we're sort of thinking that as if you're looking at the workflow of a scientist, they might read the title first, and then we can provide these TLDRs for them to read second. And if they're still interested, then go on to the rest of their workflow and reading the abstract and etc.
Isn't there a risk that you could get it like extremely wrong, given that the expectation is to take the density of an entire scientific paper and put it into a single sentence, a single crisp, dense sentence? Has it ever made any unusual mistakes?
Yeah, and I think that this is something that's important when we're looking at evaluating how well our model is doing. We should pay attention to whether or not the summaries that we're generating are factually correct, whether or not they properly represent what the paper is doing, etc.
And is that how do you find that that's the case? You have to read thousands and thousands of generated TLDRs and then tweak it a little bit and then run it again?
So the way that we went about this evaluation was we generated a bunch of TLDRs, and then we emailed the original authors of the paper and asked them, how factually correct is this TLDR? Does it properly represent your paper?
That's actually kind of awesome. That's interesting. I would not have thought that the right way to do that would be to like literally go right back to the person that wrote it and say, "How do you like this? Did we do it right?"
Right. So the alternative to that is having people actually read these papers and then do the same evaluation where they're saying whether or not these TLDRs are factually correct. But you can imagine that has a lot of overhead, both on us as researchers and also on the annotators, because they have to read an entire paper. So by going to the authors themselves, we're of course assuming that no one is a better expert in their work than the authors themselves, and we can ask them, does this represent your work?
That's like super awesome, I think. So then, do you have multiple levels? Like, there's the perfect gold TLDR that the author approves, and then a scale from the official person that knows that this is correct to what you as a reader thinks is correct. Do you like rank all the different opinions about the TLDR?
So the way we went about the factual correctness evaluation was we asked the authors to rank the TLDRs on a 3-point scale from completely factually incorrect, partially correct and completely factually correct.
And how did it turn out?
So we found that the TLDRs that were factually incorrect were generally pulling from a sentence in the paper that was maybe not a summary sentence, but was a background sentence, for example.
Hmm.
So it was still using a lot of the vocabulary within the paper, but wasn't necessarily representing the what the paper was actually introducing. But
Hmm.
on whole, we did find that our system produced generally factually correct TLDRs. So, I mean, of course, I want to be careful there because it's difficult to know when to declare victory. Our system is good enough that we can just put this into production.
Hmm.
Um, but I do think that like this is sort of the softer side of research where we have to look at this and go, okay, so is this good enough to put in front of people? Is this factually correct enough to where we are okay putting this into a production system?
Isn't that the whole state of machine learning and AI though? Is that it's amazing and it's perfect until it's utterly and completely embarrassingly wrong? There's like no middle ground.
Yeah, and as researchers, this is something that we think about a lot. Is we want to work on these ambitious problems where we're sort of envisioning this future where machine learning can make our lives better and easier. But at the same time, we want to be careful that what we're building is doing what we think it's doing, that it's not going to cause any harm, that sort of thing.
Does research like this, is it English specific, or do you adjust the models for other languages and papers in other languages?
So our data set that we introduced was an English only language. I do think that a really cool future direction of research would be to do a similar task, but on other language papers.
Hmm. So would if you were to put this into production, how would that work? Like I went to semanticscholar.org that lets me, search for scientific literature. This would be a tool that a search engine like that or Google would be able to use to give someone more context as they were exploring scientific papers.
Right. So at Semantic Scholar, what we were thinking would be really cool would be to use TLDRs wherever there's a list of papers. So a really obvious one is on search. You search deep learning, you get a long list of papers, and you're trying to figure out which ones you want to read. TLDRs might be able to help you with that. Other examples where TLDRs could be useful would be author pages, recommendation lists, things like that, where you're sort of having to parse long lists of papers.
Hmm. And then if you were to take two papers and they might be related papers, could you generate a TLDR that talks about the relationships between them and how they cite each other?
Yeah, so there is ongoing work there where we're looking at modeling multiple different papers and trying to figure out the relationship with between those papers. A way to do this would be to look at the way papers cite each other, and we can assume that when paper A cites paper B, that citation sentence is describing some sort of relationship between those two papers. And this is one way we might be able to model the relationship between those two papers.
And then is the relationship usually, we believe our paper is true because of the precedent set by this other thing, or do papers always build on each other? Is the relationship always one of yes and, or is it a relationship of we think that the findings in this other paper are invalid because?
So citation sentences have different types of intent. So you can have the sort of yes and intent where a good example would be our paper was building off of the previous work that XSUM did. So we said, yes, extreme summarization for news documents and extreme summarization for scientific documents. There are some papers that might try to disprove previous knowledge that we thought we had, or maybe you're expanding upon previous knowledge. But or maybe you're just saying this paper did really good work, and I'm going to use the framework that they introduced.
Mm-hmm. you understand advanced math and you understand what you want out of this thing. And at some point, though, the machine learning model becomes somewhat opaque, and then it takes on a mind of its own. How does one feel about that? Where it's like, I know the equations, I know what I'm trying to get out of this model, but then it spit out Y and I expected X. Why is that happening? And how much time do you spend thinking about machine learning versus thinking about your original algorithms and the math that you wanted to apply to it?
Yeah, so I think that when we're looking at this, this whole field of explainability is kind of difficult because like what do we mean when we're saying like we want to know what the model is doing, right? So we can sort of go back to our data and look at our data and be like, oh, the model is doing this because our data actually wasn't what we thought it was, or it's learning these sort of biases within our data. Other ways we can go about doing this are changing the input. So looking at, well, maybe it's picking up on this one weird thing within our data. And if we just change this one word, then all of a sudden it's giving us a different output. Looking at the models themselves, there's sort of this trade-off between, at least currently, in the current state of machine learning, there's a little bit of a trade-off between models that work really well and models that we can understand a little bit better. Because in general, the simpler a model is, the more we can understand it, or the better we can understand it. But the more complex a model is, the more it is able to pick up on these complex patterns within our data set that maybe even us as humans can't necessarily pick up immediately.
That really is interesting to me. That answers my question, because if it were something that was easily understandable or easily explained as an algorithm for us, then it wouldn't be machine learning. It would just be applying an algorithm to something. But when it starts to reach the real complexity where you needed machine learning to solve it, then it isn't possible for one human to hold in their brains and understand fully.
Right. So when we're looking at, is machine learning appropriate for this problem? A lot of times we're looking at problems that we can't necessarily write an easy deterministic algorithm for. So if I were to try to write a like algorithm that's just like a bunch of if statements for generating TLDRs, how would I even go about doing that?
Hmm. That's where machine learning and this kind of interesting work is just like a miracle to me. The idea that you could fit an entire paper through a funnel and pop out a cohesive TLDR is pretty amazing.
This field is a lot of fun to work in.
It is. Well, thank you so much, Isabel Cachola, for sharing this with me today.
Yeah, thank you so much for having me.
This has been another episode of Hansel Minutes, and we'll see you again next week.